Hello everyone. In today's video what we're going to be doing is looking at some of our textbook questions. So from page 411 we're going to look at number 10, number 11, number 12, 13, and 14. Okay, so let's scroll back up, look at the first one here. So in number 10 it says identify and correct any errors in the following solution. So you got to look through, find the error. If there is an error, you want to correct it. Now what I would say to do with a question like this is do it on your own first, see what you get, and then compare with what they have, and then you're going to be able to find the mistake. That way you're not just looking at their mistake and kind of making the same mistake yourself. So let's start out with the equation. Okay, then we're going to add 100 to both sides. So the 100 goes away because we're trying to isolate this variable to get it by itself. So we have that. Then we can divide both sides by 5. And we get a squared equals 100 divided by 5, that is 20. So we did not get 25. Okay, and then we would want to take the square root of both sides. Okay, so we get the square root of 20. And you got to make sure you put a plus and a minus, because whenever you take the square root of something, there are going to be two roots. There's a positive one and there's a negative one. So in this case, we did not get the same answer of 5. So that one is done. On to our next one. Number 11 says identify and correct the errors in this solution. So again, I would try to do it by yourself and then compare and see with what they have. So when given something like this, what you should do is look at the terms and see if there's something that's common already between them and then factor that out. So if they both have r's, I can pull an r out from both of them. So let's write that. Okay, and I'm left over with this. Now this inner piece here, you can't factor this. It's not a difference of squares, which is what they thought it was over here. They said this was a perfect square, this was a perfect square, and there's a difference in the middle. So they thought this is a difference of squares, and then they factored it as such. But in this case, it's actually not. What you want to do is pull out the r here first, and then you're only left with this. So now what we can do is we can take each of these and equate them to 0 and solve. So the first one, r equals 0, that one's easy. We just get r equals 0. The second one, we got 4r minus 9 equals 0. So add 9 to both sides. The 9's cancel. And then divide both sides by a 4. So that would be your answer. R equals 9 over 4 and r equals 0. Looking at number 12, it says write a quadratic function with zeros at 0.5 and negative 0.75. Compare your functions with a classmate, and did you get the same function? Working with a classmate again, determine two other possible functions with the same zeros. So let's start with so we're going to write a quadratic function with zeros at 0.5 and negative 0.75. So our form for this is going to be this right here. So in this form, r is going to be one of the zeros, and s is going to be one of the zeros. This is called our factored form, and it helps us find the zeros quite easily. So you can just take those zeros, plug them into there. Be careful when you enter in the negative 0.75 that you keep the negative there. So it's going to be minus 0.75, and then those two are going to change to a plus. So those will change to a plus. Now what we want to do, we don't like these decimals that are in here. We're going to change those decimals into fractions. So now we have that. To think about changing these into fractions, think about if you have 0.5, you have a half, that's 1/2, 1 out of 2, and 0.75 if you had 75 cents, you have 3/4, and 3/4 is right here. That's just the fraction. So now that we have that, to get rid of our fraction, what we can do is whatever's in the denominator, it can slide up to the variable there. So let's write that. So all that denominator there did was slide up in front of the x. So it slid up in both cases. Now the number in front, this a value, it can basically be any number that you want. Okay? So you could choose it to be 1, 2, whatever you want, just can't be a 0. To make things easier, I'm going to choose it to be a 1. So I'm just going to write that up over here. Okay, now that I have that, 1 times the stuff inside this bracket isn't going to change anything. So we're just going to have 2x minus 1 in brackets times 4x plus 3. Okay, and then our last step, what we can do is we can FOIL everything out and then get our final answer. So 2x times 4x is 8x squared. So that was that one. Then we have 2x times 3, that's 6x. Then we have minus 1 times 4x, that's minus 4x. And the last one, minus 1 times 3, that's just minus 3. Okay, and then these two middle terms we can group together. Okay, and then that's our final answer. On the next page here, for number 13, it says Sanella sells posters to stores. The profit function for her business is given by, and then they give us this function, where n is the number of posters sold per month in hundreds, and Pn is the profit in thousands of dollars. So part A, how many posters must Sanella sell per month to break even? So the term break even, what that means if you break even is that you're not going to make any money. You're not going to lose any money either, but you're not going to make any money. So your profit is going to equal 0. So in this case, our profit was that Pn. So we're going to change that to be 0. Okay, so we get that. Now to solve this, what we could do is just solve this graphically, put it into our calculator. So I'm going to put y1 as 0 and y2 as this right side. So when I graph it, because I made this one y1 and this one y2, I'm going to try to find where these two intersect. I also could have done where I just graphed this one because it's already as equals 0. So I could have just graphed this one and then found where it crossed on the x-axis. But if I graph this one and this one, then I'm just finding the intersection. So let's pull up our calculator and type that all in. So go to your y equals and put in the 0, and then in the second one, I'm going to put in this one. Just make sure when you put this into your calculator that this first negative here, you click the negative button, you didn't click the minus button. So now I can go to graph these. So what it drew, you can't see it, but it just drew a line here first on the x-axis. That was the line y equals 0. And then it drew this line. I can see there's one answer there, and then I can't see the other one. So I'm going to have to change my window. I'm going to have to move it over. So I'm going to go Window, and I can extend the x range by going to my x max, and I'm going to put it to 20. Go back to your graph. Okay, so now I've extended it out farther. I can see both of these crossing points. So let's go second, trace, and we want to find where the lines intersect, number 5. Okay, on the first curve, you can see I'm on that first one, y equals 0. So click enter. On the second curve, you can see I'm on the parabola. Move closer to the point, enter, and then one more time for it to guess. Okay, so I got x equals 6, but for us that was, we were using the variable term n, so that's n equals 6. Okay, and then I'll use the same steps to find that other point. So I click second, trace, intersect number 5, move all the way over. You can just hold it over to that other point and then click enter, enter, enter. And we get 18. So I got my two answers, n equals 6 and n equals 18. Now remember that it told us at the start that n is the number of posters sold per month in hundreds. So this is actually 600 and this is 1800. So it's going to be 600 posters, and this 18 gives us 1800 posters. So that was part A. On to part B. It says if Sanella wants to earn a profit of $5,000, so that's when Pn is equal to 5, how many posters must she sell? So again, I'm going to start with that function that we had up top here. Okay, but now my Pn is going to be 5 instead of being 0. So let's write that out. I'm just going to move the calculator out of the way. So my Pn on this side is now 5. So I'm going to write that side. That's going to be my y1. And then this whole other side is going to be my y2. So I'll type those into my calculator and find where they intersect. So go back to y equals, clear anything if you got it. Put in a 5, click enter, and type in this one. Okay, and we didn't have to retype that other one because we actually already had it from part A. But let's look at our graph. So click graph. So there's our first line. And then there's our parabola. So the y equals 5, that is this line. And then this quadratic, y equals all this stuff, that is this parabola. So to find where they cross, we'll go second, trace, find the intersect, number 5. Move closest to the point, and then you can just click enter, enter, enter. As long as you were closer there, it'll find the right point. So we got x equals 8, and again for us it was n equals 8. So I'm going to write that out. And then to find the other one, do the same process. Second trace, intersect number 5, but move now closer over to the other one. And then enter, enter, enter. And we got 16. So again, those 8 and 16 there, that's 800 and 1600 posters. On to the last question here now. So number 14, it says Samuel's hiking along the top of First Canyon on the South Nahanni River in the Northwest Territories. When he knocks a rock over the edge, it falls into the river 1,260 meters below. The height of the rock, ht, at t seconds can be modeled by, and then again we're given the function. So for part A, it says how long will it take the rock to reach the water? So if it's falling from the top, we want to find when that rock reaches the water, which will mean that it's at a height of 0. So I'm just going to write that down. Okay, so I've changed the h of t to now be 0. It's at a height of 0. And I'm going to put this into my calculator. I'm just going to put this side as y1, graph it, and find the x-intercepts. So let's pull out the calculator. And we're going to put this in. Okay, then I'm going to click graph to go look at my graph. And I can see it went up, went out of the screen, came back down, but I can't see this part up here. If I'm finding the x-intercepts, it's not going to matter anyway, but I'm going to show you how we could find that. So this point right here, this 1,260, that is going to be our y-intercept. So if that's our y-intercept, I know it's going to go way up and cross at 1,260. So what I could do is go to my window and change my y max to something that is very large. like say 1300, because that way that's more than that 1260. I should be able to, when I go back to my graph, to see the whole graph. Okay, so I got my whole graph. I'm going to zoom out just a little bit so I can see this crossing point. So click zoom, and then out is number 3. Click enter for it to actually zoom out. So now I got a good picture of my graph. I want to find that x-intercept though, so let's go second, trace. That occurs at a height of 0. So we're going to click option number 2. Okay, and then scroll over to the point at which it crosses, right there. And then we're trying to find the left bound. So go to the left of it, enter to the right of it, because it's now asking for the right bound. Click enter, and then to guess, just click enter one more time. And we got x is equal to 7, or in our case, we use the variable t, so t is equal to 7. And our time was measured in seconds, so this is 7 seconds. For part B, it now asks, what is the domain of the function? Explain your answer. So domain is this dependent variable that's in here, and we call it the dependent variable because the height depends on how much time has passed. If more time has passed, the rock's going to be at a different height. So our domain is going to be t, given that, and then we're going to put in the restrictions for t. So time, whenever you're dealing with time, time can never be negative. So time's going to have to start at 0, and it can be greater than or equal to 0. So time is greater than or equal to 0. Okay, but the maximum amount of time that we had when the rock hit, it hit at 7 seconds. So it's going to go up till 7 seconds. And then we also always put that t has to be an element of the real numbers. Sorry, I'll get my calculator out of the way. So that means is an element of, and the fancy R, that just stands for real numbers. So real numbers. Okay, and that was our last problem. So hopefully that helped you out with some of the questions.